Hi, and welcome. Today we'll be covering the 2011 Math Counts Date Sprint question number 10. So we're in the double digits now. Alright, so pause the video here and take a moment to read the question if you'd like. And then once you're back, let's take a look here. So we want to find the total amount of parallelograms in the diagram. And this sort of many sizes that's given to us here suggests to us that, that these parallelograms can be stacked onto one another to form parallelograms of different sizes. So the key to really breaking this down and getting all the parallelograms is going to be organized casework. Let's start with the smallest possible parallelogram, a 1 by 1. So I'm sort of denoting these as like length 1 and length 1, and I'm sort of organizing this into rows and columns, because we can really just imagine this to be a square grid instead of parallelograms, and asking us how many squares there are. So this should really work out. So we have 1 by 1s, of which there are 9, because there are 3 uh, that can fit in here, 3 that can fit in here, so 3 times 3 is 9. Now let's look at 1 by 2s. So 1 by 2s, something like that. So we see that there are 2 in each column, like this. So to specifically delineate them a bit more, so these are the 1 by 2s. And we can see there are 2 in each column, there are 3 columns, there are going to be 6 of this. By symmetry, there are also going to be 6 2 by 1s. Sorry, 6, yep. And now let's look at 1 by 3s. 1 by 3s, there's only 1 in each column. There are 3 of these, 3 by 1s, similarly only 3. Now let's move up to, since we can't fit anything else with 1s in here, whenever a parallelogram has a dimension of 1, we've already counted it. So now let's move up to 2s. So 2 by 2, for this, we have 4. And then, let's see, 2 by 3. For this, we have only 2. Similarly, 3 by 2s is going to be 2 again. Now it's time for 3 by 3s, of which there's only 1. So this is sort of the maximum size we can get to. And you can see I had this very organized method of counting up from 1 by 1 to 3 by 3, where I made sure that the least dimension is all exhausted, sort of, before I moved up to another dimension to be the least dimension. Alright, now we just need to add all these up to find the total amount of parallelograms. So this 6 plus 6 is 12, 3 plus 3 is 6, 4 plus 2 plus 2 is going to be 8, and we have a 1 here, we have a 9 here. So 1 and 9 just become 10, 2 and 8 become 10, and sorry, that's 12 and 8, oops, and that becomes 20 in that case. And then we have a 6, so 10 plus 20 plus 6, that's just 36. And this sort of method of adding them up pairwise is just a more organized and quicker way of adding them up, making sure I don't miss a single number. So 36 is the total amount of parallelograms we get, and that is our answer. Alright, so I hope this video was helpful, and thank you very much for watching.